Okay guys, so for today's tutorial I need to explain a few things and I want you to explore on your own. I think learning happens best when you explore and you discover. I'm going to start you off, get you rolling. So what the focus of this section is to see translations and shifts of graphs. So for example, if we have the function y equals 2 to the x, that gives us an exponential graph that is multiplying by 2 starting here. So this times 2 will be, next one will be 2, 2, 2, 2, 2. You can see the table here. These are all being multiplied by 2 times 2 times 2 times 2 times 2 and so forth, right? You can make it go on 3, 4, okay? So all of these are multiplying by 2. All right, so that is this graph right here. It's the basic one. We're going to reference this one all the time. All right, so you open up a Google Sheet. So I want you to make one of these and share it with me for your homework. I'll show you how to do that. So all you do is go to your Google account, right? And just put Sheets. And if you're signed in with your account, you'll be able to make a Google Sheet. So here's Google Sheets, and all you do is put plus, and that'll make you a new Google Sheet. Okay, so I'm going to make one. Let's see if you guys can see how I do that. All right, this one has columns and all that. So on Google Sheet, you have your notes here. I'm going to put the basic function, and this one is y equals 2 to the x power. 2 to the x power. Okay. And I want to explore on Desmos what happens when I gotta close this. How do you close this? Close that. Whoops. Okay, I'll kind of play around with this. So this is the table view of the graph, and I can go here and press this, and that'll bring me back to the equation. So here is our basic graph. Okay, so I'm going to put a note, basic function. Okay. All right, so I'm going to that's 2. What about 3 to the x? What does that look like? So here's 3 to the x. And it looks like it's more steeper, okay? Still hits the same intercept. And if you see the data here, the numbers are multiplying by 3. So that's why it's steeper versus this one, the basic one, was multiplying by 2. So this one's multiplying by 3. The blue one is multiplying by 3. So it's going to get up faster. So it's going to like reach up faster. Put this back. So you can see the numbers. It goes 3, 1, 3, 9. It's faster. The other one was 1, 2, 4. See that? So it's getting up a little bit slower. So let me close this off and we'll do 4. See what the difference of the visual and also the difference of the y's. Okay, so we'll put 4x. Okay, so we'll be playing with this in your calculator as well. 4 to the x. And if you look at the data for that one, okay, so go ahead and test it out on your phone too. Pause it right here. This one's multiplying by 4, so it's going to be 1, 4, 16. See, by the 2, this one's already at 16, and when this one was at 2, it's at 9, and in the original one, the basic one, would be, excuse me, it's only 4. So you see, this is why This is why the graph looks like it's tight. It's more tight right here. In reality, it's what it looks like, but what's happening is the y's are increasing exponentially more. And of course, we can check with different numbers. Go ahead and type 5 to the x, 10 to the x, 50 to the x, you know. Make it go that way as well. So I'm gonna close these off. So you gotta like press this tool and then press this one and then that one. So I'm gonna put 10 to the x. And see, that one is shaping up just a little bit narrower. You can zoom out. Okay. All right. You want to understand why it's getting steeper. Okay. It's getting steeper because we're multiplying the numbers by 10, and this one we're going to multiply everything by 1,000. Okay. And then see, it's steeper. So if you look at the data for this one, it goes from 1 to 1,000 to 1,000,000. Okay, so that's why it looks like it goes straight up. So this is a very steep climb. As you can see, the steepness of the graph is determined by the number that is being multiplied by. Okay, so let me close this off, and then I'm almost done closing these. All right, so no matter what number's here, I mean, you can put a gajillion and it'll be very steep. It doesn't look like it ever passes into the negative ones. It goes straight up. So in your Google Sheet, you could say that the base, you know, you can call it generalization, right? Generalization, right? Means what happens as the base increases, the graph gets steeper. And you could say in the deep thinking, right? Deep thinking. Okay. Why does it get steeper? Yeah, because the numbers, the y's, are being multiplied by a larger number. Okay, so as it gets larger and larger, the y's get multiplied. This one they get multiplied by 3, so by 4, by 4. So the last number, you know, was the ratio, like in our geometric sequence, would be 4, and the ratio for the smaller ones would be a smaller number. Okay. Okay. So that's a generalization. Now, next, let's put. Is there positive numbers? Now let's put negative numbers here and see what happens. Now, with negative numbers, okay, it's very important to understand this idea. Negative 2 to the x versus y equals, in parentheses, negative 2 to the x power. Okay, and they're very different. Okay, let me go ahead and block this one off. As you can see, the black one is not. It's not anywhere. It's not graphed. And why is the black one not graphed? Okay, it looks like it graphs one point, and then another one here. Kind of hard to see. But only this one's being graphed. And then let's look at the data, okay? The table. And compare the two. All right. So this one right here is negative 2 to the x. All of the answers are negative because we're multiplying by positive 2. So we got to do this first, right? So 2 squared will be 4. like if it was here. Now it becomes -4. This, it weights. This is not part of the 2, okay? Versus this one is multiplied, -2 times -2, which would give 4. So we're going to focus on this one right here, this idea, okay? So we'll put this one back on. And if the base is negative, it's not, actually here it is, there they are. So, there they are, they're the black dots right here, okay? It's because we had to type the numbers, okay? See, now they're showing up. And you see here, they're alternating. They're alternating, so that it goes up, down, positive, negative, positive, negative, positive, negative. So these are negative. All the ones with odd numbers are negative, and all of the ones with even numbers are positive because they're multiplying back and forth. But it can't actually connect them. They're just dots, okay? All right, so we can make a generalization of that, okay? If the base is negative, it should be in parentheses. Then it's technically alternating the y's, these ones right here, the y's will alternate from positive to negative, because you can have an example like -2, and it's got to be in parentheses for it to work, to the third power is actually -2 times -2 times -2. So there's 3 -2 to be multiplied, which would equal -8. Okay. Let me make these font a little bigger so you can see them clearly. All right, sorry. All right, I'm going to wrap this up with decimals, okay, so you can see that. All right, so here's our base function, and let's put a decimal in the 2. Instead of a 2, instead of making it bigger, let's make it 1.2 to the x. And then, so make it a 1.5 to the x. Okay, so the original one's the red one. So it looks like the bigger the number, the closer to the red. Closer to the, so the smaller the number, the flatter it is. So the red one, oh, never mind. I haven't put my exponent yet. Here we go. So then, how about $1.01? Look at that. That's the blue one. So look at that. It's still exponential, but it's far away. So we can make a generalization of that one. Okay. If it's a decimal, the smaller the decimal, closer to 1, the wider it is. Okay. My time's going to run out right now, so I will make another video shortly. Now go ahead and play around with this, but only change the base and make a generalization.